Hello again, welcome to another video. In this video, we are going to use the limit definition to find the area under the graph and evaluate some integrals. But first, let's try to see and understand what does the limit definition say and how can we use them. Basically, the limit definition says that the integral from a to b of f of x dx is exactly equal to taking the limit when n approaches positive infinity of the sigma notation f of x sub I times delta x. The thing is, what is x sub I and what is delta x and what is f of x sub I? X sub I is equal to a plus I times delta x. What is a? A is my lower bound of the integration, and delta x is, we're going to define it right now, so delta is going to be b minus a over n. What is b? B is the upper bound of the integration, and a is the lower bound of the integration. N is just basically the letter n, and I is the letter I. So this is all about this. Let's try to apply this to the following example and see how can we make use of this limit definition and find the answer to the integral, or basically the area under this graph. So it says evaluate the integral 2x minus 1 from 0 to 3. The steps is, first of all, we have to know what is my a, what is my b. My a is the lower limit, or the lower bound of integration is 0, and b is 3, which is the upper bound of integration. The second thing, I'm seeing delta x in my formula, so I have to find delta x. And for finding delta x, I only need b and a. So I understood b and a. Now I can find delta x. So delta x going to be b minus a, 3 minus 0, which is 3 over n. So I found my delta x. Then I can find x sub I, because I needed the delta x, which I have right now. So I can use it to find the x sub I. So x sub I going to be a, which is 0, plus I times delta x, 3 over n, or I can simply write it as 3i over n. So this is my x sub I. And what is f of x sub I? F of x sub I going to be basically f of 3i over n. What is f of x? This is f of x. This is f of x. So this one, we're going to find the area under this graph. So I'm taking this as my f of x. So now I have to plug 3i over n into x. So it's going to be 2 times 3i over n minus 1, or basically going to be 6i over n minus 1. This is my f of x sub I. Then what? Now I'm not considering the limit first. First of all, I have to understand this one and evaluate the summation. Then I'm going to take the limit of the summation. So let's try to find this one here. So I can say sigma I equal to 1 up to n of f of xi delta x. This is exactly equal to the sigma of 6i over n minus 1 times delta x is 3 over n. So let's try to find this one. I've also explained the sigma notation in my other video, which I'm going to include it in the caption below. So go and see it just to try to understand what does sigma notation do and how can we use them here. Basically, this 3 over n should be distributed or multiplied by 6i over n once and by negative 1 once. But the thing is, I need my sigma either to be in terms of I, or either in terms of like a constant number. I don't really need to put any other non-related things in front of the sigma notation, just to make the process easier. So this would be what? 3 over n times 6 over n I. I only have to keep I in front of the sigma notation. So I, and move the other things back to the sigma notation. So I have 3 over n times n, 6 over n, that will give me 18 over n squared, minus, so 3 over n times 1, That's going to give me 3 over n. And I don't have anything in terms of I. So basically it's going to be 3 over n, sigma notation of 1. This is what it is. Let's try to evaluate this one. This going to give me 18 over n squared times the sigma notation of the first degree going to be n times n plus 1 over 2 minus 3 over n times n. This is what it is. So n with n cancels out. I'm gonna get 18 times n plus 1 over 2 n squared minus 3. Now when I found the sigma notation of this one, now I can take the limit of this expression. So let's say limit when n approaches infinity of 18 n times n plus 1 over 2 n squared minus 3. So here I can see that the numerator and denominator have the same degree. So the highest degree of the numerator is n squared, and the highest degree of the denominator is n squared. When the degree of both the numerator and denominator are the same, the limit's going to be the ratio. The ratio is 18 over 2. I'm going to get 9 minus 3, which is 6. This 6 is the answer to the integral, or basically using the limit definition to find the area. So this 6 is the area under this graph. Let's try to see another example right here. This is a bit more challenging. The reason is because we got higher degrees, and this would be a little bit challenging, but we're gonna see how we can solve this one. Again, we have to find our a and b. So a is 0, b is 2, delta x is b minus a over n. It's going to give me 2 over n. My x sub I going to be a, which is 0, plus I times delta x, or I can rewrite it as 2i over n. This is my x sub I. And now I have to find f of x sub I. So f of x sub I going to give me f of 2i over n, or basically just plug 2i over n into this equation. I'm gonna get 2i over n squared minus 2i over n. This would give me 4i squared over n squared minus 2i over n. This is my f of x sub I. And then the thing that I need is the sigma sign. So I equal 1 up to n of f of x sub I times delta x. This would be what? This would be the sigma of 4i squared over n squared minus 2i over n times my delta x is 2 over n. As I said before, this 2 over n should be multiplied by each term. So once by this one and once by this one. So the sigma notation can be rewritten as, so I have the I squared. This is the only thing that should be in front of the sigma notation. So I will write it as sigma n I. This is I squared. What else I have? I have 2 times 4, which should be 8 in the numerator, and n times n squared, which gives me n cubed of this one. So this is about the first sigma. I have the minus here. I'm going to put it. I have I, so the only thing going to be in front of the sigma sign is the I. So I, what else? 2 times 2, going to give me 4 for the numerator over n times n, which is n squared for the denominator. So let's try to evaluate this one right here. So this is going to give me 8 over n cubed times. This one we explained that before. It is n times n plus 1 times 2n. Yeah, it was plus 1, just to make sure. And it's over 6. Yeah, that's right. Minus 4 over n squared times n plus 1 over 2. So I replaced the sigma notation of I squared with this one right here, as I explained in my previous video, and I have changed this one, the sigma notation of I, with this one. So now let's try to evaluate it and see how it goes. So let's see, what can I do right here? So this one up here, let's take the limit of this expression first. So limit n goes to infinity of 8 over n squared times n plus 1 times 2n plus 1 over 6 minus 4 over n squared times n plus 1 over 2. Thing that I can do right here is just check whether the degree of both numerator and denominator are the same or not, because if they are the same thing, so the answer to the limit going to be the ratio. So let's try to see. So this is n times n, going to be n squared times 2n, going to give me 2n cubed. So I can simplify this 2 with this 6, so it's going to be 3, and on top I have n squared. I only care about the high degree, so this one is not really, does not really affect the limit process. So this going to be, so I have now n cubed on top and n cubed in the bottom, so the limit going to be the ratio, so 8 over 3 going to be the answer to this part of the limit, minus I have right here, let's try to see, so n times n going to give me n squared, and on bottom I have n squared as well, so the limit going to be the ratio, which is 4 over 2, which is 2. So the answer to this question going to be taking a common denominator, which is 3, so 8 minus 6, which is 2 over 3. So this is the answer to this question. Now we try to understand how can we start and how can we go further and everything related to these questions by using the limit definition. I hope you liked the video. We'll see you next one.